Well, g'day, Ken Coulson back with Creation Unfolding, and we're going to start a new series here. I thought what I'd do is do a series on historical geology. So if you're a geologist, you know what that is. This is a basic class that you do in geology, but it's a great class for us to do together on the channel because it looks at the entirety of Earth history from its inception all the way through till the present day. Now, I'm going to be using a secular textbook. So this is actually the textbook that I'm going to be using if you wanted to follow along. I think there's a later edition than this one out there, but it's more or less about the same. And I'm going to be looking at historical geology from a secular position, but as a creationist, I'm going to be sort of interpreting certain events or certain things that we see from a creationist perspective. So I think you'll find it interesting, whether you're a Christian or maybe you're not a Christian, you're doing a historical geology class. I think you'll find it interesting anyway. Okay, so let's kick off here. And to begin with, we're going to start with the Precambrian. And we're going to start specifically in the Hadean. Now, first thing to know is an eon. What is an eon? Well, essentially, geologic time, and again, we're talking from a secular perspective, conventional perspective, is broken down into different divisions. So geochronologically speaking, we have what's called an eon, and there is a smaller subdivision of an eon, and that would be an era, and then there is a smaller subdivision again, which is a period, and then you have epochs and ages as well. In other words, you want to break these down into smaller divisions so that we can handle them better. So we're looking at the largest time segment, which is going to be an eon. And we're looking specifically at the Precambrian. Now, you'll notice that the words Precambrian there have quotation marks, and that's because technically the Precambrian is not an eon, but geologists often use it colloquially. So we just talk about the Precambrian eon, although it's technically not an eon. But you'll see it over here in the chart. You can see here, this is the Precambrian eon. So in Earth history, we only have two eons. We have the Precambrian and we have the Phanerozoic. And so here's the Phanerozoic right up the top. From a conventional perspective, the Phanerozoic is only the last 500 million years, and the Precambrian is about 4 billion years, or the rest of Earth history. So you can see that the Phanerozoic only makes up a small portion of geologic time, again from a conventional perspective. And the reason is, generally, this division is there because in the Precambrian, there's sort of not a lot happening in terms of life. It's pretty basic, simple organisms, bacteria, maybe some basic eukaryotic life, and some other bits and pieces that we'll talk about. But when we get into the Phanerozoic, that's when we see an explosion of multicellular life, or metazoans, and this is kind of what we consider the most interesting part of Earth history from a historical geologic perspective. Now, Phanerozoic means phaner, which means visible, and zoic is life, so it's visible life. So you understand why it's called the Phanerozoic. But we're not talking about that. Right now, we're just talking about the Precambrian. Okay, so when we're talking about geochronology technical-wise, then we've really got to talk about the Hadean, Archean, and the Proterozoic. And so you'll see here again in our geologic column, you've got the Precambrian, which is sort of the colloquial, non-technical term, and then it's broken down into the Hadean, Archean, and Proterozoic, and each one of these are eons. And so we're going to look at the Hadean and the Archean eons in this lesson. And so from a conventional perspective, we're stretching from 4.6 billion years ago to about 2.5 billion years ago. All right, and I think the first thing I want to do is I want to talk about the origin of the Earth. So if we're starting off in the Hadean, this is basically the very, very first rocks that form on the Earth. And the idea is that there's a whole bunch of extraterrestrial dust out there. So you've got planetesimals, you've got asteroids and meteoroids, and it all sort of coalesces and collapses under the influence of gravity. And because of that, it gets really, really hot, and all of that rock eventually melts, and you end up with sort of a molten ball. and I'm being really simplistic in the way I'm trying to explain it. So that's sort of the conventional perspective. Then over time, what happens is you get the heavier elements like iron and nickel under the influence of gravity will make their way down into the center of the Earth and collect as the core, and then lighter elements and compounds will make their way up into to the top of the Earth, where it will crystallize to become the crust. So that's the basic idea. Now, I did want to talk about this secular model a little bit. What should we, I'm a creationist. What should I, as a creationist, think of this sort of secular model of the evolution of the Earth? Is there anything that I, as a creationist, can garner from this scientific knowledge? And I think there is. I think there are some aspects of the way in which the secular scientists have thought that the Earth is constructed. I think that it's helpful to me as a creationist. And it's not just me that thinks this, there are other creationists that think this as well. And it's because we want to think of creation in a lot more of a dynamic fashion than creationists have in the past, in a sort of a static fashion. So yes, God creates everything ex nihilo, and he creates the earth, forms the earth over 6 literal 24-hour days. But are there processes that are going on during that time? And if there are, do those processes in any way correlate to some of the scientific theories that we've looked at? I think that I would say yes in the affirmative. I think some of that is actually the case. And other creationists think so as well. So this is John Baumgartner. He wrote some articles in this book called Radioisotopes and the Age of the Earth. He's a 6-day creationist. He's also a geophysicist. He's written a number of articles that have been published in the secular literature, right? So he's written a whole bunch of articles in the secular literature. The guy knows what he's talking about. He's looked at the secular model, sort of the differentiation of the crust out of the mantle and the core out of the mantle. So you've got the core, the mantle, and the crust. And he thinks that this concept of differentiation of a core from the mantle and a crust from the mantle, it actually makes sense. And in terms of that model, he says this. He says, this means, in other words, because I think there's some cogency to this secular model, this means that, in my opinion, the processes of nuclear transmutation, which is radioisotope decay, mantle convection, so think about the movement of heat in a medium, magma generation, which is just essentially basically the melting of rock to get magma, and how you get different kinds of magma, cooling, together with a spectrum of tectonic and geologic processes, must have unfolded at rates many orders of magnitude faster than we observe today, because he's a 6-day creationist. So it's like, yeah, he recognizes the cogency and the helpfulness of the secular model about the formation of the earth. He likes the sequence of events, but he doesn't believe that the time involved is true. And I would pretty much hold a similar position. And there are other creationists as well. So this is Answers in Genesis's Andrew Snelling, and he also is thinking in terms of rapid processes during creation week. So he says this. He says, what is clear from the biblical record is that the perception of a human observer on the earth during creation week would have been that countless millions of years of earth history at uniformitarian rates had been compressed into 6 days of normal experience. Kind of think of it like a time-lapse movie. Okay, the other person I want to talk about is Danny Faulkner. He is also with Answers in Genesis. He's an astronomer with Answers in Genesis. And he talks about the formation of the moon kind of in a similar way that the secular community think of the formation of other planets in our solar system. In other words, the collection of dust and planetesimals and asteroids and things like that collapsing together under the influence of gravity. And so he says this, in similar manner, the assembly of astronomical bodies on day 4, so not just the moon, but the earth and other planets, may have been rapid, but not instantaneous. What he means by that is there's process involved. It's not sort of ex nihilo and it's fully formed with a core, a mantle, a crust, rivers, mountains, etc. It goes on to say, the day 4 cratering hypothesis proposes that many craters bear testament to at least the last stages of that assembly. So he doesn't say it outright, but when he says the last stages of that assembly, he's talking about that coalescing of debris, extraterrestrial debris collapsing in on itself. Now, because he understands the implications and what creationists might say, he goes on to say, some recent creationists may respond that this is the same as the evolutionary history of the solar system. But then he goes on to say it's not, and here's why. First of all, it would have been really rapid, taking a day or less to accomplish rather than millions of years. Second, this would have been an event directed by God rather than random processes. And third, being during Creation Week, elements of miraculous rather than purely physical processes that we see operating today likely were at work. And so I think with a lot of that, I would agree. So essentially, he's saying that the concept of the sequence in which the moon was maybe created or the earth was created may be correct. We just don't accept the fact that it was natural processes, and we don't accept the fact that it happened over billions of years. So there's a few creationist scientists who also hold to this idea of processes at work during Creation Week. So what does that mean then for the creation of the earth? So all of these guys, and myself included, what we would generally think then is that maybe God created sort of a ball, if you like, of molten material, and he then worked on that molten material. So under the influence of gravity, the heavier elements would make their way down into the core. You'd have other processes that are going on like fractionation and partial melting, which would cause very light compounds, what we call silicates, that are formed of silicon and oxygen. These would make their way up to the top of the molten body and then would crystallize and cool. So the earth would begin cooling from the outside in, which means you would end up with some kind of a solid crust. I think that general model has a lot of merit. I'm not saying it's right. And if the scientific evidence changed, I'd be totally okay with that. But I think as a scientist, I don't see any initial problem with the sequence of events. And in fact, God may have actually done that during Creation Week. And there are hints of that in the text. So for example, you can see in Genesis where on day 3, you got the entire biosphere, the vegetated biosphere, grows rapidly in one day. It actually talks about things growing, it seems, from seeds. You've also got the water, the earth, which comes out of the water. So that's, again, a movement, sort of process, a forming of the physical realm. It says that the waters were gathered together into one place. So again, the idea of processes and movement seems to be coherent with our current scientific models of how the earth was formed. Like I said, if this changes, that's no big deal. What is ultimate, what is our ultimate authority is the Word of God, and it's Genesis 1. Now, I do want to say this about Genesis 1. Genesis 1 is not a scientific textbook. God didn't write Genesis 1 to give us a scientific perspective on how the universe was formed. But it is an historical document. In other words, the events that occurred in Genesis 1 happened in space-time history. So that means we can't write them off. So on the one hand, it's not scientific, fine, but on the other hand, it is a series of historical events. And because of that, I can't just symbolize Genesis chapter 1. It's history. In fact, it's written as historical narrative. Almost all Hebrew scholars acknowledge that. So I see Genesis 1 in terms of a historical document, even though it's not trying to explain the science. Okay, so let's go on now. So that's the formation of the Earth. I think it worked in terms of processes. Over time, God works on this molten ball. He differentiates, that just means separates out the core from the mantle. He differentiates or separates out the crust from the mantle. So now you have three parts of the Earth. And that, by the way, is fully in line with the rest of Genesis, where he separates light from darkness. He separates out things during creation week. And in fact, when you get into theology, when you get into the rest of theological history, God is always separating out one thing from another, which is kind of interesting. So let's get now to the origin of the continents. So from a secular perspective, I'm going to give you the secular perspective. You have the molten planet, you have the lighter materials that are working their way out of the mantle, making their way, okay, up to the surface because of gravity, because these materials are less dense. Things, what we call silicates, and they contain silica and oxygen. And they're a lot less dense than a lot of these other heavier elements and compounds that make their way down into the core. So we have this lighter material. It's at the outside of this molten ball, and it solidifies into, you can think of it as one great big oceanic crust. So the oceanic crust that we have today is made of basalt. And so, and being very simplistic here, the idea is that the early crust of the Earth was basically made of basalt. It didn't have mountains on it. It was very flat. And you can think of it kind of like how we view the oceanic crust today. Now, again, the idea is that this crust is broken into many different plates. So we have actual plates that make up this solid planet. And this is really interesting, that because of volcanoes and perhaps impacts by comets, which are made of ice, we ended up with a world that had a lot of water on it. Now, up until recently, geologists and scientists thought the Earth had quite a bit of water at the surface, but not that much. But just recently, scientists have determined that the early Earth, so this is the time that we're talking about, from a conventional perspective 4 billion years ago, that the early Earth was literally covered with water. So let me read this quote from a Harvard research program. According to a new Harvard-led study, geochemical calculations about the interior of the planet's water storage capacity suggests Earth's primordial ocean 3 to 4 billion years ago may have been 1 to 2 times larger than it is today, and possibly covered the planet's entire surface. Now, I say that because in Genesis 1:2, we read the earth was without form and void, and darkness was over the face of the deep. Now, again, like I just said earlier, we don't want to take scientific information and necessarily read it back into Genesis 1. That's what a lot of 19th century Christian scientists did. They would take something they found out about in science, and they correlated it with Genesis chapter 1, with the events of Genesis chapter 1. And this is called concordism. And it's where you take something scientific and try and read it back into Genesis 1. We don't want to do that, okay? We don't want to start looking at scientific conclusions, which are just hypotheses, and then reading them back into Genesis 1 and saying, aha, look, there we go. He knew all along. The Bible had it right all along. That essential method of trying to connect science with Scripture has been shown to be false. So we don't want to do that. Having said that, are there some scientific conclusions that do actually accord with what the Scriptures teach? And I think this is one of them. Again, if this changes and they come up with another hypothesis and they say there was no water on the early planet, it's no big deal. It doesn't affect my reading of Genesis chapter 1 because that's my ultimate authority. But can I use some of these scientific models? Can I hold them tentatively to help me understand how God constructed the planet? And I think, yes, I can. So I just think it's interesting that you have this early Earth that's covered with water, and that's exactly what we read about in Genesis 1 verse 2. Okay, so how do the continents come about? Because right now, in our secular model, we just have basically a crust that's broken into plates and this crust is basically like oceanic crust, so it's like basalt. So here's a picture of basalt up here. You would be very familiar with basalt. It's that black rock, volcanic rock that you've probably seen around the place. And the early Earth's crust then would be made of this basaltic material. But that's not what the continents are made of today. Today, the continents are made of more felsic igneous material. So again, simplistically, think granites. So a granite is over here on the right. You'll notice that the granite is a much, much lighter color. Granites typically tend to be sort of a whitish color, a gray color, or a pink color. And more than likely, you're familiar with granite. You've been out on a hike, you've been to the mountains, and you've picked up granites. They have these black flecks that are in them as well. That's a granite. Well, the continents are primarily made of these granitic kind of rocks. They're not made of these basaltic rocks, these black rocks over here, but scientists say that the early Earth's crust was actually made up of this black sort of rock, basaltic rock. So how did the continents that we have today come about? So again, this is their model, right? And essentially what they believe is that this basaltic rock melted. And when this basaltic rock melted, some of the compounds in that rock, which were lighter or less dense, because they're less dense, made their way up above the heavier, denser basaltic rock and were sitting on top of the heavier basaltic rock and became continents. And the scientists have done experiments to confirm this. So they've taken basalt, so like this here, they've taken a basalt like this, they've taken it to the lab, and they've melted a portion of that rock. And the minerals that are in that rock that have a lower melting point, they're the ones that melt first. So the material that melts, so that's the material that has a lower melting point. These materials are typically called silicates. We talked about that earlier. They're a less dense, lighter mineral. And so they separated off these silicates. They let these silicates harden and turn back into rock, and then they do it again. And every time they do it, they see that the rock gets lighter in color, lighter and lighter and lighter, until eventually they end up with a granitic rock that looks just like this. So they can actually do this in the lab. They can make granitic rocks from basaltic kinds of rocks. And so they've hypothesized that something like that must have happened in the early Earth. So here is their hypothesis. So we have these plates. So that's what this corky looking material is here. All right, that would be a plate. And there's 3 plates here. And if we go over to this diagram, this represents those same 3 plates. What they think is that these plates, they sort of smashed into each other, and then one got subducted under the other. Now, because it's subducted and the plate goes down into the mantle, it gets really, really hot. And according to modern secular scientists, again, the early Earth was producing a lot more heat, which meant that these basaltic rocks that were getting sort of subducted down into the mantle, they were melting, just like in the way that I just suggested. And the lighter material, under the influence of gravity, would make its way up, and it would hit the bottom, okay, of these denser basaltic oceanic crusts. Then that material would make its way through the crust because of gravity, and it would sit on top of this early Earth crust. And because of its density, it would literally float there. So you can think in terms of like putting an ice cube in a glass of water. the ice cube floats because the ice cube is less dense than the water. So in the same way, this granitic material that comes from this basalt, it begins to float at the top or on top of this denser oceanic material. Then, and that's what this third picture represents here, these bits of granitic continents, which are called microcontinents, begin to collapse, and eventually you end up with one great big continent. So that's sort of the current theory for how granitic continents form. And like I said, is it possible that that's the way that God caused the creation of our granitic crusts? I don't know. I mean, maybe. As I said, if we think in terms of processes, and even though Genesis 1 doesn't describe this, there's nothing to suggest that God didn't do that. It's highly possible. We can think again in terms of sequence of God forming the earth, but doing so in 6 literal days, because that's what it clearly says in Genesis chapter 1, and it's reiterated again later in Exodus and Deuteronomy, where God says, "For in 6 days I made the earth," and so he established the Sabbath day and the work week over 6 literal days as well. Okay, so that's the current theory. So this is actually a picture of the Pilbara region in, now let's see, this would be Western North Australia. And what you're looking at are these small microcontinents. Okay, so there's one here, one here, one here, one here. There's a little one there. And you can see that these things seem to be connected, although you have this darker material that runs around these microcontinents. So this rock is considered to be, from a secular perspective, around sort of 3 to 4 billion years old. It represents the Archean rocks of the earth. And by the way, when it comes to the Hadean rocks, remember that when we looked at Earth history, there's the Hadean rocks, and then there's the Archean rocks. Well, as far as Hadean rocks, I don't think there actually is any. So they may have just a couple of places in the world where they actually have rocks that date older than 4 billion years old, even though they think the Earth is 4.6 billion years old. We do have a lot of these Archean rocks. And of course, with the secular theory of Earth's evolution, these Archean microcontinents continue to coalesce until you end up with a large continent. Now, and I'm going to talk about this because I think it's really, really important from a creationist perspective. As it turns out, that theory of how large continents are constructed has just come under attack in the secular scientific literature. So here's a paper that was published in just December of 2024. And in that paper and several other papers written by these authors, they say, look, our model of how we get these large cratons, it's not right. It's wrong. Notice the title of this paper, Geochemical Mapping of Lithospheric Architecture, just the architecture of a craton. It disproves Archean terrain accretion in the Yilgarn Craton. In other words, it shows that the accretion of these Archean microcontinents actually happened. Now, this is really interesting. Now, the Yilgarn Craton is actually in the southwest of Australia. It's not in the north. That picture that we just saw was the Pilbara region. This is another region in the south, but it's very, very similar. And what these guys are saying is that perhaps all of these Archean terrains, they're actually not microcontinents at all. Their hypothesis, and I could be wrong on this because it gets pretty complicated, but their hypothesis, they believe that these microcontinents actually did not accrete. Instead, all of this was actually one great big continent, and through magma-generated heat from the Earth, it caused this basaltic crust, parts of it, to actually turn into granite in place. So you didn't have plate tectonics going on. You don't have these micro continents accreting. Instead, you already had a large continent, but it was just sort of changing into a more felsic continent, or has more granitic elements to it. Like I said, it's pretty complex. But the reason that I want to point this out is not necessarily because, oh, we need to know this, but it's to show that scientific theories change. This idea of microcontinents accreting over time to get large continents, this is the established theory for how cratons are formed. And yet now you've got these scientists coming in saying, no, we've got it all wrong. It's got nothing to do with that. There is no accretion of microcontinents. You start out with a big continent that just sort of gets changed over time. That's important for us as creationists to remember, because scientific theories, they just change all the time, which is why we can't trust in them ultimately for our ultimate appraisal of what is true. We've got to go back to Genesis 1. Now notice, even if the scientific theory changes, and let's just say these scientists are right, does that change our interpretation of Genesis 1? Absolutely not. Do you see how, when we stick with the authority of the Word of God, the historical reality of that chapter does not change, and it doesn't matter what the scientific world hypothesizes? That's important for us as creationists to keep in mind, because some large hypotheses have been overturned in the past, and I believe in the future we're going to see this continuing overturn of hypotheses as science continues to change, which is why we've got to completely rely on what God has said in His Word. Okay, moving on. We want to talk about Archean life, and I'm going to talk about this briefly because I have done a video on this. I'll put a link in the description where I'll get into this in more detail. But I just want to touch on some basics here. So, of course, in the secular model, life has evolved from non-life. Life has evolved from inorganic elements, inorganic material. And we call that abiogenesis. And the idea is that over time, certain bits of inorganic material came together and voila, formed a living cell. Now, we can't say that's evolution, because evolution, biological evolution, has a number of other mechanisms included in it. So this is not evolution. They don't call it evolution. It's just the fact that this inorganic material came together and boom, life formed. So they think that this evolution of life occurred from a conventional perspective 3.4 billion years ago. They found microscopic evidence of that in terms of bacteria in Archean rocks. So those little cratons that we were looking at, they found fossil evidence of bacteria in those rocks. Now here's what's really interesting, is this picture on the left here, that's actually one of those bacteriums, right? And you'll notice that its external architecture is very distinct. Okay, it has lots of these little filaments that are coming out from it. Well, it turns out that the same kind of bacteria exist today. So these two pictures on the right, the one in the center, the one on the right, that's actually modern forms of what we think is the same bacteria. Now here's what blows me away. The theory of evolution says that everything is evolving. It's constantly evolving. It never stops evolving. Well, how do you get the same organism after 3.4 billion years? I mean, that's a long time, and yet you've got essentially the same organism. Now, there are rescue devices. There are all kinds of rescue devices to explain that. I appreciate that. But for me, I think the best explanation is just there is no 3.4 billion years. I think it's the best way to explain that. All right, moving on. We know that when it comes to abiogenesis, we go to the Miliguri experiment, I think it was of the 1950s or 60s, I can't remember, where they produced some compounds that are used, that go into making living systems. And since that day until now, they've continued to do these kinds of experiments. And they have produced altogether, what they've produced is 19 of the 20 amino acids found in all life. So they've managed to do that. They've managed to create basic sugars that are in organic living organisms, and they've managed to produce the bases that we find, for example, in DNA. So they've managed to produce these really, really basic molecules. But that's all they've been able to produce. I want you to think about that. Billions and billions of dollars have gone into this research for 100 years. Tens of thousands of people have committed their lives to this to show that abiogenesis works. And guess what? Basically, we've come up with a big fat zero, okay? It just doesn't work. We're going from these basic compounds to anything even remotely that looks like life, like even a protein, is essentially impossible. We'll look at the numbers in a minute here. The big problem here is information. In order to get information, you need to have information, and that is a scientific fact. So what are the possibilities, for example, of randomly coming up with even a small protein? Let me play this video for you.
When applied to the origin of life and the random formation of large biomolecules, probability theory clarifies the limitations of chance as a creative agent on the primordial Earth. For example, what are the odds a single protein could form exclusively through the blind interactions of chemistry? Our target is one smaller than average molecule made from 150 amino acids, each aligned to ensure a folded chain. Researchers have calculated that on the ancient Earth, the probability of success was 1 chance in 10 to the 164th power. That's one correctly sequenced protein chain for every 100 million trillion 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 failed attempts.
Okay, so you get the point. Essentially, we're talking about it's impossible. Now, some people are going to say, well, hang on, it's still a number, right? I mean, okay, it's really, 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 really unlikely, but hey, it's still a number, and I'll believe in that. Let me give you an analogy to show you why that kind of reasoning is ridiculous. I want you to imagine that you and your wife go on a holiday. And I've given this analogy in the video that's linked into the description, but I'll give it again because I think it's a good one. You go with your wife and you go to America, you land in sort of a very small city, let's say Dayton, Ohio, and you rent a car, you go out to some, back of the boonies restaurant in nowhere land. And you're in that restaurant with your wife, and lo and behold, you bump into a friend from high school. Now, I want you to think, what's your first reaction going to be? You bump into your friend from high school. You're going to be like, whoa, what in the, how are you here? What in the world are you doing here? What's the chances of that event happening? Now, the chances of that are pretty high, okay? The chances of that are pretty low, right? It's probably not going to happen, which is why you'd be freaked out if you saw your friend there. But you might think to yourself, well, I guess it's a coincidence, right? I mean, yeah, okay, it could be. But now I want you to imagine that not just one of your high school friends is there, but every single one of the 25 of your high school friends are in that restaurant. You walk in the door and all 25 are there. And it's been 20 years since you've been at high school. Now, what are you thinking now? Are you thinking, well, that's just a coincidence? No, of course not, right? You're starting to think, something's fishy here. Something's going on. Now, when it comes to the statistics of what would be required for that to happen, guess what? It has a number, just like this number. But if I gave you that number, and by the way, it's probably a lot less than this number, would you in any way believe that it was an accident? And the answer is no. So even though there's a statistic, you still know essentially, it's intuitive, right, that that is impossible. And it's the same thing with these kind of statistics. Now, there's something else I want to draw out here that's really important. Like I said, what would your reaction be when you saw these 25 people? Would you think, like with one person, you might consider that it was a coincidence? But with 25 people, no. You know something's not right. In other words, there is so much in terms of specified complexity here that you know there's no way for all of those events to come together, to coalesce into this very specified, complex scenario. You know that can't happen, and we call that design, right? And I bring this up because Richard Dawkins, he's famously known for saying that things that sort of look designed, he just says, well, they're not really designed. They might look designed, but our mind is really deceiving us. And we've sort of got to get away from this primitive notion that things that are complex are actually designed. We just got to forget that. Well, let's put yourself in this situation. If you were that man and you had your 25 school friends in that room, is that what you would do? Would you see all of this specified complexity or design and just say to yourself, it's not real? Of course not, right? No, your intuition tells you that this specified complexity, whether it be an organism or whether it be a sequence of events like this situation, tells you that design is present. And in fact, you go on to find out that it's your birthday that day. You know that it's your birthday, but it turns out it's your birthday. Your wife has been planning this high school reunion around your birthday for years. She's been in contact with all these people. You guys happen to be millionaires, so you paid for all their tickets to come out and to meet you in that restaurant on that day at that time. That is a lot of specified complexity, and you know it, which is why Dawkins's idea that we just sort of need to look at things that are complex and say, well, they're not really designed anyway, is ridiculous. Okay, just want to leave you with a few examples of that design. So here, for example, is one example of specified complexity that we find in our cell. So this is where the cell is making proteins. It's protein synthesis. And so here we have an mRNA. So that's what this is, this long piece here. That's mRNA or messenger RNA. You've got rRNA, which is this ribosome. You can think of that big blue thing as like a factory. And these other things, these triangle-shaped things, are sort of called tRNAs. And what these tRNAs are doing is they're bringing in material. Let me play that again. These tRNAs are bringing in material or a code, in what's called an anticodon, to match up with a code that appears on this mRNA. Now notice this mRNA goes into this factory kind of almost like an old ticker tape machine. Remember those old ticker tape machines? You'd kind of put the tape in and you'd click the numbers and it'd come out the other side. That's exactly what's happening when your body is synthesizing proteins. So you've got these complex parts. Now, these other parts here, this tRNA, the mRNA, not the mRNA, but the tRNA and the rRNA, they are very, very complex nanomolecules that have a lot of folding going on so that these machines can complete a very complex job. This is specified complexity. And when we see it, we don't say, oh, that's not designed, do we? We shouldn't do that. We should say, oh, that's designed. There's an intelligent designer. Here's another one. This one is actually the duplication of DNA. So this happens again inside your cell. Here you have a number of different proteins involved. So you've got this thing here on the outside in the middle here. It's called a helicase. Oh, there it is. Okay, so you've got a helicase right here. Oh, sorry, here's the helicase, the blue thing. And it's splitting the DNA molecule. And then you've got these polymerases over here, these other two proteins, that are actually adding nucleotides to the two strands to make sure that you get your DNA duplicated. Again, incredibly complex. Lots and lots of proteins. Now, when we looked at the chances of one small protein coming together by itself, and we saw that astronomical number, now consider these are large proteins that are highly complex, and there's lots of them, and they're all working in coordination with each other. That's specified complexity. And the last one I want to show you is probably my coolest. Again, this is going on in your cell. This thing here is called a kinesin motor. What this is, it's actually a little motor inside of your cell, and it's carrying this great big vesicle on its back. Now, inside the vesicle are biological components that the cell needs. Let me play that again, because I don't think it's going to play back. Okay, so here it is again. What's amazing about this little molecule is it has like these little feet, and these little feet walk on these microtubule highways that are found within your cell. I mean, these little motor proteins are absolutely amazing, and they blow my mind when I think about them. Now, we've only looked at just three of the literally thousands of complex systems, and that's only inside your cell. We haven't even gotten to our heart, to our kidneys, to our eye, or to our brain. We haven't even gotten there yet. So, given all of that, I trust that you, the viewer, can see that this idea of abiogenesis and of life sort of forming from inorganic molecules, it just is ridiculous. There has to be an intelligent designer out there. Okay, so that finishes us off for this first part in our historical geology set of lessons that we're going to be doing. Next time we get together, we're going to be looking at the Proterozoic, but we're still going to be in the Precambrian, and we're going to be looking at a lot of stromatolites, which was my area of research while I was doing my PhD. So that's all from me, Ken Coulson here at Creation Unfolding. Please pound that like button and share this video on your social media platform if you thought it was in any way interesting. Even if you get just one person who watches us, it doesn't matter. Go ahead, pound the button, share this video. And of course, as always, I appreciate prayer. Thank you and goodbye.